Justin, the Lesser Dog Tutorials, and this is episode 3 in the Retro FPS tutorial series for Unreal Engine 5. The first part of this video is going to be focused on a little bit of C++, which will enable the ability system in Unreal so that we can actually use that to facilitate how our weapons will fire. To start things off, we want to make sure that Unreal is closed out because we will be running Unreal through Visual Studio. In your main project folder, you can see where your uproject file is, but we want to deal with this SLN file here. And so just double click that to open that in Visual Studio. And we will be using the debug feature up here at the top. You can see this, I have it set to Development Editor, Win64, and the local Windows debugger here. And every time we want to test out Unreal, or the game in Unreal, we're just going to hit this local Windows debugger, and it will load up the application. And what's cool about this is that it will tell you if there's errors in the C++ file, and you can choose not to open Unreal if there are errors. So with Unreal open, we're just going to go to the plugins under Edit, and we're going to search for Ability System. Gameplay abilities is what we're going to be using, and we want to enable that. And then it says it needs to be restarted. We don't need to restart it, so we'll just close this. And so when it's closed, it should stop debugging, and it did. So now we have the ability system ready to go. And the first thing we want to do is if you look over on the Explorer, Solution Explorer, you'll see there's a source folder. And what we're looking for is this build.cs file. So open that up. The reason we need this is because we need to add a few dependency module names, but in the private section. So just like up here, we're going to add a few into this section here. And the ones we're adding are going to be gameplay abilities, and then the comma goes after the quotation marks, and then game play tags, which should also be surrounded by quotation marks, and then a comma. And then the last one is gameplay tasks. And then we can save. I'll hit the save all up here. And I like to, over here on the Solution Explorer, I usually right click and hit build. And then I just look down here at the bottom to make sure that there's no errors. Okay, so it says now build, 1 succeeded, 0 failed, and that's what we're looking for. So everything worked well. Keep in mind this can take a while. Now go ahead and click that local Windows debugger so we can load up Unreal again. And now that it's open, in the C++ classes folder over here, we're going to go inside the Retro FPS tutorial. And what we'll do is create a new C++ class, and it will be of the type character. And we're going to call this Retro FPS character. And the idea is that this is going to be the base class that all characters, even the player, will derive from, because it will hold the stats or the attributes that the characters will have. So probably just health and armor. So we'll just create that class. And then we can head back to Unreal. You'll see that's being added. So I'm hitting reload all, and I'm not going to stop debugging because I'm going to head back to Unreal and add another C++ class. And this time I'm searching for attribute set. And I'm just going to select this top one here, attribute set. And then I'll hit next. And I'll just call this Retro FPS attribute set. And I'll create that class as well. And then I will reload all, and then yes, I will stop debugging because I don't need to be in Unreal right now. So I also don't need these this build.cs file, so I can close that. And now I have these two header and CPP files open for these two classes, for the retro FPS character in the attribute set. So let's fill out what the attribute set will be. So the first thing we'll do is add the header for the ability system component, because we'll be using this header along with the generated and attribute set in core minimal. However, make sure that the ability system component header is above the generated header. This one needs to be the last one. Next, I'm going to add this macro here, and that's going to help us with getting and setting these attributes. Next, we'll add a public section under the class, and we'll just add the constructor for this class. Next, under the constructor, I'm going to add two fGameplay attribute datas, one for health and one for armor. And these are the two stats that we're going to have in this game. So every character that is in this game, enemies and player alike, will have these attributes, but they'll just be set at different amounts. And lastly, in this header file, I'm just going to add a U property that's blueprint read only, and I'll put it in a category attributes, and I do this for both the health and the armor. And then under each of these attribute datas, I use this attribute accessor macro, and I just pass in the class name and then the name of the variable here. And then in the retro FPS attribute set CPP file, all I'm doing is just building that constructor out and not doing anything else. Over in the retro FPS character header, we don't need the setup player input component and we don't need tick, so you can delete those. Then under the game framework / character.header file is that we'll just add the gameplay tag container header and then the gameplay effect types header, and that's surrounded by these brackets here, and then the ability system interface header. Because now, using that ability system interface, we can implement that here by going public ability system interface. And now that this is implemented, we can then add under the constructor, we're going to add a function called getAbilitySystemComponent, which is a constant override and returns the ability system component. And this is from the ability system interface. With that added, we need to go to the CPP file and remove these two that we removed in the header. And then when you save that, it should clear up any sort of errors that would appear over here. However, the only other thing is that we should implement this function here. So if you right-click and go to Quick Actions and Refactoring, you can actually create a definition in the CPP file, which is what we'll do here. And then it opens a little viewing window into the CPP file. You can close that, and you can see it added right here. Next, in the header, under Generated Body, I'm adding an ability system component that I'm calling ability system component. That's very creative, I know. And then I'm adding the retro FPS attribute set that we just made, and I'm calling that attributes. And this is so that each character derived from this will get an attribute set, and then each character also derived from this will get its own ability system component added to the character in the engine. And then down here, under the second public section, I'm creating two U properties. Both of them will be blueprint read only, both of them will be edit defaults only, and both will be in a category called retro FPS. The first U property is going to be a subclass of the gameplay effect class, and that will be something that we create in the editor, but it just means that there will be an area called default attribute effect that can use anything derived from gameplay effect, but only things derived from gameplay effect. Secondly, and the other U property is a T-array of another subclass of anything that is derived from a gameplay ability, which again will be used in the editor. And I'm calling this default abilities. Now over in the CPP file, we can start coding what happens in begin play and using the variables that we made. At the top here in the constructor, all we're going to be doing is taking this ability system component and creating a default sub-object of the ability system component, and we're going to call it ability system comp. And then for attributes, the same thing. We're creating a default sub-object of the type retro FPS attribute set, and we're calling it attributes. All this is basically doing is just taking these two variables that we made and creating them and adding them to the character. And then for the ability system component function that is called get ability system component, all we're doing is returning the ability system component from here. The next thing I'm going to do is add the ability system component header first up here at the top. And then in the begin play, after the super begin play, I'm going to check if the ability system component is not null. So all I'm doing is saying if ability system component. And if it's not null, it will return true. And then I'm going to point to a function on the ability system component called init ability actor info, passing in this and this. Next, right after we do the init ability actor info, we're going to check and see if the default attribute effect is null or not, because we want to know if we are going to be setting the default attribute effect and applying it to the character on begin play. Then, once the default attribute effect has been found to be valid, we're going to create an effect context handle called effect context, and then we'll make the effect context here. And then we'll add a source object to the effect context equaling this. So this is the thing that the effects will be applied to. And then we're making a gameplay effect spec handle called spec handle. And then we're pointing to the function called make outgoing spec. And we're passing in the default attribute effect. The level is going to be 1. And then we are also passing in the effect context that we just made. Then, if spec handle is valid, we're creating an active gameplay effect handle called GE handle, and then we're pointing to a function called apply gameplay effect spec to self. And then we're passing in the spec handle with a pointer .data.get. And this section here will apply any sort of default attributes that we assign to this character. And lastly, we will, after we do the default attribute effect check and assigning, we're going to check if this has authority. And if it does, we're going to go through the default abilities right here. And we're going to do a for each loop. So basically, we're looking for each subclass of gameplay ability. As we said, this is here. And then we're doing an and symbol. And we're calling each of these the startup ability. And we're going through the default abilities array. And then for each of these, all we're doing is pointing to a function on the ability system component called giveAbility, and we are passing in a gameplay ability spec, and we're passing in the startup ability dot get default object, and then pass in a 1 and a 0. And that should be all that we need in order to get this ability system up and running. So what I'm going to do is right-click in the Retro FPS tutorial up here, and I'm going to say build and make sure that there are no errors. And it looks like there is an error. So the issue was that we need to include the header for the Retro FPS attribute set up here. And then if we build, once that has been included, you'll see that it has succeeded. So now we can launch the local Windows debugger, which will open Unreal Engine, and then we can continue implementing this ability system. Let's get started implementing this ability system using blueprints and all of the assets within the actual editor itself. So if you open the FPS player and you click the class settings up here at the top, then over here at the parent class, you can select the Retro FPS character class that we made earlier. And when you do so, you'll see this ability system component appear on the character. And this is because in our C++ file, you'll see that we add that component on the constructor. Now, let's go to the blueprints folder and we'll create a new blueprint class. And if we extend the all classes section, then we can look for a gameplay ability. And you'll see it right down here, gameplay ability. That's what we want. So we'll call this GA for gameplay ability underscore retro FPS ability. And this will be the gameplay ability that we use as our base, and then all abilities will derive from this. So we can also, while we're at it, go ahead and create a folder called abilities. We can move this gameplay ability into there. And then we can create another folder called widgets. We'll move our HUD into there. And then we can create another folder called player. And we'll put our FPS player in there. And the player weapon base we'll put in there. And then another folder called interfaces, which may only just have one interface, and that's the player weapon interface. Beyond that, I think we could probably make another folder called weapons, and we'll put the weapon pickup and pistol into that. And we can just leave it like that. So let's open up our retro FPS ability and try to get this thing going. Now that we've opened the retro FPS ability, we can kind of look around and you'll see that there is two events. And the first one is activate ability, which defines, as it says, defines what an ability does. And then we have on end ability, and that's what is called when the ability is over. And then if you were to select the class settings, the class defaults, you'll see a bunch of stuff over here, all kinds of different things. And this ability system can be pretty confusing. So I'm also not an expert on it. So I'm just going to kind of show you a kind of a basic way I do this stuff. And really, I would suggest kind of diving deep into it on your own time to try to figure out how it can best serve your project. And in the description, I'll have some links to some places where you can read more about this gameplay ability system. So let's get started on what we'll be doing, where at the beginning, where we activate the ability, we're just going to first run a function called commit ability, which will make the ability actually fire. And then once that's been done, we're going to run a custom event that we're going to call, just add that custom event, and we'll call it wait for event. And so when we run this, what this is going to do is run a function called wait gameplay event. And what it will be doing is when we fire the ability, then we need to do a function that will wait to see if we've successfully used the ability on an enemy. So in order to determine what we're going to be looking for, we can just promote this event tag to a variable, and we can call it weapon event tag. And then after this, the async task, we want to promote that also to a variable, and we'll call this gameplay event wait task, because we want to be able to cancel this if we hit someone. Otherwise, we're going to have a timer up here that will run for a certain amount of time before we can cast this ability again. But during that timer, we want to be waiting for an event where if we hit someone, it can tell us that we hit someone, and then we can do what we need to do before the timer's up. So then, once the event has been received, we're going to apply gameplay effect to target, because once it hits an enemy, we want to apply the effect. We haven't defined what the effect is yet, but we know that when it does return the correct tag, we do want to apply this. So for the effect, we can go ahead and promote that to a variable that we'll just call weapon effect. And it can be changed, depending on what the ability does, because all abilities will inherit from this. And then the payload here, if you pull up from that, we will break it. And you can see all the kind of stuff that comes in this payload variable here. We have like event tags and the instigator and who the target is and a bunch of other stuff that we're not going to really use. So the thing we are using though is this target data, and that's just going to be plugged into this target data here. And then you can kind of minimize this to clean things up just a little bit. All right, so now that that's done, we can create a comment here, and I'll just say wait for gameplay tag. And again, you'll see more on this a little later. So now that we're waiting for an event, we are running this where we're now waiting. And then this will continue to wait, by the way, until end ability is called. So then we want to do another custom event. So we'll just create a custom event over here, and it will be called fire weapon. And this is going to be to override, because we are not going to define what this is in here. We're going to define what this does in children of this blueprint. So with that, good to go. We can run the fire weapon event. So it'll start listening for game tags right here, and then it will fire the weapon, whatever visual elements we want to do, or line traces and things like that in other abilities. And then we can go ahead and just say that this is the activation portion of the blueprint. But now what we need to do is we're going to run a task wait delay. And this is going to run instead of making this a variable, we're going to get cooldown time remaining. And again, this is something else that we will be doing later. Whatever cooldown we assign to this ability, this task wait delay will wait for that amount of time. And then we will again promote this task to a variable, and we'll call this fire rate delay task, which essentially is just going to be how fast can you fire the weapon, and that will be defined on the cooldown. And then on finish, this is when we run the end ability function. It's right here. So with that ended, now this will fire, event on end, and really all we're going to do is a couple of cleanup things, like take this gameplay event wait task and check if it is valid. And if it is valid, we'll continue on and end this task. We'll just move that to the top here. And again, for the other task, we're doing the exact same thing. We're checking if the fire rate delay task is valid. And if this, by the way, if this gameplay event wait task is not valid, we're still going to move on to the next part. All right, so if this is valid, again, we're ending the task. And then if this is done, we want to run a function that we're going to call reset. This could be anything, and we'll override that if we need to in the children of this ability. And the only other thing I want to do in this blueprint, other than comments and stuff, so this bottom one will say end ability cleanup. And then up here, be called ability duration. I want to make one more function that I'll call apply effect. So now we'll just create a couple inputs, and they'll both be actors, and this will be the attacking actor. Then we'll create another one called target actor. And so what we want to do is take this target actor and we're going to cast to the retro FPS character, which is the class that all of our characters derive from. And then we will send gameplay event to actor. Now to determine what actor, what the event tag, and what the payload is, we first need to pull out from this retro FPS character that we're casting to, and we'll get the ability target data from the actor. And then we have this return value here, and then we can, from that, make gameplay event data. And once we've made that, the gameplay event data output goes to the payload. And the event tag, we can actually pull in this weapon event tag here. That goes to that. So whatever we assign later, that's the tag we're looking for. And then we take from this retro FPS character, what we're wanting to do is plug it into the target section, because that's what this is, the target. And then we can minimize this again. So you can see that the instigator is still inactive. We're not going to be filling that in, or the event tag here, just the target's all we need. And then we take this attacking actor and we'll go above here, we'll add a reroute node. And then from here, we will get the instigator. And this instigator will then be plugged into the actor input of this send gameplay event to actor node, and that will conclude what we do in this function, which can be called from any child actor. We just pass in who the attacker is and who we're hitting. Now I'm going to open the BP pistol, and we're going to fill out some stuff in here. And first, what I'll do is comment this top area, just to be equip weapon. And then I want to add all of the functions and things that will animate the gun firing, and also turning that point light on momentarily so that we light our surroundings with the firing of the gun. So first thing I'll do is I'll add a custom event, and I'll call this shoot pistol. And then the first thing it will do is run another custom event that I'll call light flash. So shooting the pistol will first do the light flash, and then the light flash itself will be set hidden in game, but we're going to be using this on the point light. And we don't want it to be hidden, so that's going to be false. And then we will do a delay. And we'll do a 0.25 second delay. And then we will set the actor hidden again. And that will be true. All right, so that's all that we're going to do for the light. And then, once the light flash occurs, then we're going to set the flipbook of the weapon down here at the bottom. Oops. And then we're setting it to be the fire pistol animation. And then we need to do a delay so that once the animation is complete, it will go back to setting the flipbook to be the idle. So instead of fire pistol, we go back to the idle pistol. From the weapon flipbook, we get the flipbook duration, which would be the length. And then we just put that into the delay, so now it's going to only delay for the amount of time it takes to run the animation. So we'll just say that this is the pistol fire animation. Now let's go to the blueprints, into the abilities, and the gameplay ability, the base ability. Let's right click it and we'll create a child blueprint. And we'll just call this pistol ability. And we might even put player pistol ability at the beginning, because we could have an enemy pistol ability be derived from this also. So now open up the player pistol ability, and we'll add some stuff in here to make it fire the actual gun and do what we need to do. So we don't really need this activate ability or on end ability. That stuff will already be taken care of in the parent function. What we want to do is override the fire weapon event, because that will be fired right here. So if we just look for that function to override, it's right here, fire weapon. And now we can do some custom stuff in here. So the first thing I want to do is create a function called getPlayer. And we will run getPlayer. And then we will add another function called getWeapon. And then we'll run getWeapon. And then I want to create a variable that will be called player pistol weapon component. And this will be of the type pistol, BP pistol right here. And then while I'm at it, I'll create another variable called player, which will be of the type player. Right here, BP FPS player. So anyway, take in this player weapon component, which all of this will be filled out after we complete just the chain of events that we need. So from this, we're going to check if it's valid. And then if it is, we're going to shoot pistol. Then we'll run another function that we'll make called getLineTrace. So we'll get the line trace now, so the animation is being done, but then we also want to see what we're shooting. And then the getLineTrace will return, so we'll add a return node, and the return node will have an output that is of the type actor. And we'll just call that actor, no big deal. And then on the back of the event graph, we'll take the actor and we're going to cast to FPS character, retro FPS character. And with that done, we will then apply effect. And this character is going to be the target, not the instigator. And the player here will be the instigator. And remember, the apply effect is this function here, where the player is getting the gameplay event and the target is receiving the payload. So let's just comment this out so we know what this is doing. Fire weapon, actually fire pistol. Specifically, that's what this is doing. Okay, now let's figure out all of these functions that will help us actually fire the pistol. So the first thing we want to do is do an isValid check. And we're just checking if the player is valid already. If it's not, we're going to cast, otherwise we're returning, so we'll add that return node. So if it is valid, we don't need to do anything. If it's not valid, then we're going to get actor info, which comes in the gameplay ability. And then if you right-click this return value, you can actually split it and you'll see all of the information that can come from a gameplay ability. But really all we're doing is taking this owner actor and we're casting to the player. And then setting the player to be equal to what we get. And then we can leave. That's really all we're doing in this. The next thing is we're getting the weapon. And the first thing we'll do is check if the weapon is valid. If it is, good, then we can leave. And if it's not, we need to get the player, get the weapon, get the child actor from the weapon, and cast to pistol. And then, just like before, we're setting the variable to be what we cast to. And the next one is the line trace. So for the line trace, first thing we do is we get that player. We get the camera on the player, because that's our eyes. Then we're going to get the world location. And then we're going to also get world rotation. And basically we're going to run this line trace by channel. And what we need to do is, on the rotation, we got to get the forward vector. And then from this world location, that's where it's going to start, is the camera's world location. Then what we're also going to do is multiply this forward vector by the range of the weapon. So it's straight out from the camera. So what we need to do is have some sort of weapon range variable that we can use for every weapon. So that would be best put in the retro FPS ability itself. So if we added a variable here, we could just say weapon range, make that a float, and then click this little eyeball to make it editable outside of this. And then in here, if we see the class defaults, we can set the range of the weapon to be something like 5,000, something really long for now. And then we can get that weapon range. And we'll just multiply the return of this by the weapon range. So now we're moving out forward from the camera by this amount. And that will be where the line trace ends. So it starts at the camera, and then depending on where you're facing, straight out, multiplied by a certain amount, see how far we go, and that's where it ends. And then we can also make sure that ignore self is checked. And then to figure out what is returned, we need to break the hit result. And what I would like to do is just check if the actor is valid. So is valid. And if it is valid, we return the actor. So simple as that. The pistol is now, it should be doing everything we need. We can test it out and see kind of what it's going to do and see if it actually fires the gun. But in order to do that, we need to go to the project settings. And actually on the left side, we can find input. And then we need to bind first an action mapping. And this one will be called fire weapon. And we'll just make that left mouse. All right. And then we can move over to the player blueprint. And we have to add that input. So I'll just put it down here. And now we have to figure out what happens, how do we fire an actual ability using an input action. What we're going to use is a function called try_activate ability by tag right here, and it's part of the ability system component. And all we need to do is say what tags using this gameplay tag container, so we can actually promote this to a variable, and we'll just call this, you know what, we'll just leave it as gameplay tag container. And all we'll need to do is say, okay, what tag should it do? So if we just if we expand this add new gameplay tag area, we can add a tag, and it's separated by a period. So we could say player.fire weapon. How about that? And so now we have this player.fire weapon, and it's going to try to look for an ability that's on the player that has this tag. And also, let's uncheck allow remote activation. Now that the tag has been added, if you look over at the class defaults, in the retro FPS section, there's the default abilities array, and that's what we made in the C++ file. So let's add one, and we'll just find that pistol ability to make sure that it's part of the player's default abilities, so that when we search for this tag, we can actually find it in the list of abilities available to this player. And over in the player pistol ability, we have this tag section, and if we make the ability tags be equal to the one we're firing in the player, that should be all that we need in order to actually fire the pistol. So let's load up the game, and then we'll go pick up that pistol. And then if I click the left mouse button, it will actually shoot the gun, which is cool. The only issue is that there is no cooldown, and while it is animating correctly, not interrupting, you can see that the flashing light occurs every time I click. So we can actually just add really quick a cooldown function to this ability, and you'll see how that works. That will prevent us from firing again until the cooldown is up. So let's do that. So if we go to the blueprints and we go to the weapons, then we can create a new blueprint class, and we'll search for a gameplay effect. And this is what we're looking for the cooldown. So if we just select that, we can just say that this is a GE for gameplay effect underscore pistol cooldown. And then if we open that up and just dock this up here, we don't need to do anything in this event graph at all. All we need to do is say that up here at the duration policy, that it has a duration, and the duration magnitude can be whatever our cooldown would be in seconds. So we could just say that that is 0.2. And with that done, all we need to do now is determine or tell the ability when this is over. So in the granted tags section, the combined tags will show all added and removed. So all we need to do is do the added, and we'll create a new gameplay tag right here, and we'll just say player.pistol.cooldown. And then you'll see that it has been added into the added section, and that's all we really need to do. Combined tags, it will show it there. You can see it's already selected. So with that done, we can move on and go back to the player pistol ability. And all we need to do in here is the activation blocked tags, meaning this ability is blocked if the activating actor/component has any of these tags, meaning all we need to do is add this cooldown tag, because if the cooldown is active, which it will be when we fire, then you can't fire again until it's over. The duration will of 0.2 seconds or whatever we did, 0.25. No, 0.2 seconds. When that's up, then this will go away. So down here at the bottom, we have that cooldown gameplay effect class, and all we have to do is pistol cooldown. So if we were to play to test this cooldown out, and we pick up that gun, then watch the light is only flashing. I'm clicking it really fast, but it's only happening every 0.2 seconds. And we could just really watch this happen if we did 1 second. So let's try 1 second and test it again. Now I'm clicking it like crazy, and it's only happening every 1 second. So now we have a cooldown situation figured out, and it's very easy to add cooldowns. You know, it's just as simple as making a gameplay effect, setting its duration, and assigning the tag. Last thing I want to do for this video specifically is create bullet holes on the wall when we're not hitting an enemy. So in order to do that, I'm going to open up the player blueprint, and I'm going to add my object pool component that I made. And this, I have a video to make these, and it's not that long, and I'll provide a link in the description. But once you complete that, then you'll be able to add these object pools to your actors. And what I want to do is pool the bullets. So in order to do that, we'll need to create the actual bullet. So I'll create an actor, and I'll call it BP. Specifically, we'll say it's a pistol bullet hole. And then we'll open that up. I don't need to do too much in here. We just need to add the paper sprite, I believe. We'll just call this the bullet hole. And then we should turn this 90 degrees. And the sprite we're going to choose, we need to make a sprite of the bullet hole. So we should have the bullet hole here. We imported, I believe, in the last video. So now that that's created, I can go back to this and I can add that source sprite. And then I think I have to move it 0.1 on the X just to get it out from the wall a little bit. So now that that's done, let's see if that will work. So back at the object pool, we can select the, it has to be a pooled object. So make sure that the class settings, we switch it to pooled object. Sweet. Now we can choose it in the object pool right here. So we'll do the pistol bullet hole. Say that the size is 10. And then we can compile and save that. And then over in the player pistol ability, what we want to do is open the get line trace function, and we're going to make some edits. So if the line trace says that the actor is valid, we're going to leave. We're not making a bullet hole. But if it's not valid, then we do want to create a bullet hole. So we'll take this player here, and we'll get the object pool. And then we will spawn pooled object. And that goes here. All right, so from the return value, we got to say set actor location. And then we will set actor rotation. And that goes here. And we can just move this line over top here. And we won't leave from this because we don't need to do anything else. It's just going to hit the wall and create this thing. So in order to find the location where the bullet should hit, we have to use the impact point as the location. And then the impact normal is the rotation. We just have to get the rotation from X vector. And then that return value becomes the new rotation. All right, let's see if that works. All right, so no bullet hole should be made because we don't have a gun. Pick up the gun, and now we shoot. But it looks a little off-center. Just a smidge off-center. So I actually did something incorrect in this line trace. We aren't going from the forward vector multiplied by the range to the end, we're supposed to be adding it to this location first. So once that has been added, then we go to the end. And that should be everything that we need. So now let's test it, and then we can pick up the gun, and now we shoot, and it is actually on the location. And these red lines are just the debug, draw debug type. I just set it to persistent for debugging to figure out what was happening. So now that it is lined up, there are like two things I think that we need to fix. One is the cooldown for the gun is a little long. So we'll change that to 0.2. Now that that's done, the only other thing is that the bullet texture does not use our sprite material. So now it does, and then if we were to pick up our gun, you can see the bullet holes are there, they're just a little dark. So now with that out of the way, we can also see that the bullets, once we reach 10, they start moving away just like they're supposed to because of the object pooling system that we have. All right, I think that's going to be it for this video. Now that we have the gun working, now we just need some enemies to use our ability on. So if you like the video, please hit like, please subscribe, and I'll see you in the next one.